Welcome, everyone. For today's prep, we're going to start looking at the product rule. And this is going to be a special derivative rule that allows us to calculate the derivative when we have a product of two or more functions. So we'll look at the formula, make a couple notes, and then we'll look at an example. So first of all, what is our product rule? So this tells us how to differentiate when we have one function, call it f of x, times a second function, and we want to differentiate their product. So there's a multiplication sign right there in the middle. So we have some x terms here, and we have x terms here, and we're multiplying them together. So how do we differentiate our way through that multiplication? And what this rule says is we write down two copies of our product, and then in the first copy, we apply the derivative to the first part, and then in the second copy, we apply the derivative to the second part, and then we put a plus sign in the middle. All right, so there's a little bit more here than we might be thinking. So it's a very natural idea to think that if we had one function times another function and we wanted to do their entire derivative, it's a very natural idea to think, well, let's differentiate the first function. So we'll differentiate the first function, and then we'll differentiate just that second function, and then we'll just keep the multiplication sign in the middle. Unfortunately, it doesn't work like this. So these are not equal. So when we have a product of two terms, we can't just differentiate the first term, differentiate the second term, and then keep the multiplication sign in the middle. It just doesn't work like this. So it's a little bit more involved. So we're going to try an example. And kind of a tell that we might need to use the product rule is essentially if we see two variable terms being multiplied, chances are we might need to use the product rule. So we're going to look at one example, example 1. So we have this function, 2x cubed minus 5x times 3x plus 1. So technically this is an example where we could just multiply this whole thing out. We don't have to use product rule. But let's actually see how product rule works. So what we have here is our function is composed of this term, which involves some x's, and then the second term here, which also involves x's. And it's not written, but it's implied there's a multiplication sign right there in the middle. So we have a product of two x terms. So product rule does work. So let's see what it would look like. So we're going to calculate y prime. And the way we apply the product rule is we just write down two copies of our product. So 2x cubed minus 5x times 3x plus 1. And then we write down a second copy. So 2x cubed minus 5x times 3x plus 1. So we write down two copies of our function. And then in the first copy, we apply the derivative to the first factor. And then in the second copy, we apply it to the second factor. And then with product rule, we put a plus sign in the middle. And then once we get to this point, now we just have to keep differentiating. But now we've kind of broken our way through that multiplication sign. And now we get to differentiate each of these terms individually. So if we finish this up, derivative of 2x cubed minus 5x, well, if we differentiate that 2x cubed term, we get 6x squared. And then differentiating the negative 5x gives us negative 5. And then we have our 3x plus 1. This is outside the brackets, so we don't have to do anything to these. They just stay the same. And then finally, we get over here, and we have to differentiate the 3. We have to differentiate the 3x plus 1, and we get 3. And that's it. We got our derivative. Now, one little thing here. When we do the product rule, don't forget the parentheses around each of these. So the parentheses are needed. We don't really need them around that individual 3, but we do need the parentheses here, here, and here. If we forget them, well, technically it's not correct. So you just got to be careful with that. And that's really the idea with product rule. So we'll try a few more examples in class, but I also want to look at quotient rule. Very similar feel. So we're going to look at quotient rule. And this gives us a way, well, to calculate the derivative when we have a quotient of functions. So when we have like a fraction. And again, this comes down to knowing a specific rule, knowing a specific formula. So this tells us how to differentiate when we have a fraction where there's x terms on the top and x terms on the bottom. And the way we can kind of implement this quotient rule is similar to product rule. So if we're trying to differentiate a fraction, we can write this fraction as a product. So we write down the first, the top function times the top function times the bottom function, and then we write down a second copy, top function times the bottom function. And then in the first copy, we apply the derivative to the first part. In the second copy, we apply it to the second part. But now what's different is with quotient rule, we have subtraction in the middle. So this top here should look very similar to the product rule we just did. The only difference is it's a subtraction sign in the middle. And then we make this into a big fraction, and we square the original denominator. So this is our quotient rule. And again, we know we might need to use quotient rule if we see that we have a fraction and there's a variable on both the top and the bottom of our fraction. So let's just try an example to see how the quotient rule works. So here we go. We have this function y, which is x squared plus x minus 2 divided by x cubed minus 6. And so when we look at this, we have our top function, which has x's in it, and we have our bottom function here, which also has x's in it. So this really is a quotient of two functions of x. We're dividing one function by another. So if we want to calculate the derivative, we first have to kind of differentiate our way through that division sign. So we have to break our way through the fraction here first. So we're going to try quotient rule. And the way quotient rule, the way you can kind of implement the formula is we're just going to write this as a product. So we'll write the top function, which is x squared plus x minus 2, times the bottom function, x cubed minus 6, and then we do two copies of that. So x squared plus x minus 2, and then x cubed minus 6. And then just like product rule, in the first copy, we apply the derivative to the first part, and then in the second copy, we apply it to the second part. But with quotient rule, we put a minus sign in the middle. And then we're going to make this into a big fraction, and we take our original denominator and we square it. And now we've differentiated our way through that fraction. We've broken through. So now we get to differentiate each of these individual pieces. So for the x squared plus x minus 2, if we differentiate the x squared, we get 2x. And then if we differentiate the x minus 2, we just get plus 1. So derivative of x is 1. And then the minus 2 is just a constant, so that differentiates to 0. These terms are not inside the derivative brackets, so we're done with those, so they just kind of stick around. And then for our x cubed minus 6, well, derivative of x cubed is 3x squared. And then the derivative of minus 6, that's just a constant, so just 0. And then this is all over our x cubed minus 6 squared. And we're just going to stop there. Once we get the hang of this, we might want to try to simplify these fractions down a little bit. And most of the simplifying happens by multiplying things out and trying to factor the numerator. We don't really do too much to the denominator normally, so we would just leave this as is. So if we wanted to go further, we would multiply this out, multiply this through, and try to combine like terms. But we're just doing the derivative for practice here, so we're going to stop there. One little comment though, we do need the parentheses here, 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 and here. So again, just a little comment, just like with product rule, we do need our parentheses. They're important. And that's really the idea. So in class, we're going to try a few more of these. I do just want to go back up to our formula. I forgot to mention something. So the quotient rule, just like product rule, there's something worth mentioning. So a little note here. So it's very natural to think that if we have a fraction, top function and divided by another function, it's very natural to think that if we wanted to differentiate this, well, we could differentiate just the top and differentiate just the bottom and keep the division sign the same. And just like with product rule, differentiation doesn't work super nice with multiplication and division. There's a more involved process here. So unfortunately, this is incorrect. Well, just, you don't want to try this. So that does not work. So if you're trying to differentiate a fraction, you can't just differentiate the top and differentiate the bottom and call it the end. We got to use the quotient rule here. So unfortunately, this method, which perfectly natural to think, just like the one for quotient or product rule, perfectly natural to think that this would work. Fortunately, it doesn't work like this. All right, so like I said, in class, we're just going to try more of these product rule and quotient rules. So we'll see you then. Bye-bye.